Good morning, ladies and gentlemen. Welcome to the technical forum of fuel cells, of hydrogen and fuel cells Europe at the Hannover Fair 2022. We're having a lot of good presentations of the newest technology, and the next presentation will be about coating on bipolar plates. And we got the PVD marketing manager here from HEF Group. It's Guillaume Chevret. Welcome on the stage.
Hello, thank you so much. Thank you for the invitation and the presentation. As you said, we will focus our speech this morning on coating on bipolar plates. So you know these kind of parts that you can find on fuel cell today. We want at HEF to contribute to the success of the hydrogen move for the future of mobility. And this is why we introduced for the first time on this show our last development, the last 3-4 years on this coating, and the applications, what we reach, and what we will, how we will industrialize this solution in the coming 1-2 years. So a few words about HEF. If you don't know HEF, our competitors, for example, are Balzers, Ironbone, many others which are doing some coatings for different applications. We are coming from the tribology science, and we have a lot of experience in different types of coatings, such as, for example, DLCs, which are very well known, and we are a bit more than 3,000 people over 86 plants now in more than 20 countries. Turnover 275 million euros last year. And one small specific thing, the company belongs, at least the majority of the shares belongs to the employees. So that could be interesting if you want to join. So that's HEF. We are in many fields of activities. We will focus today on mobility, but of course today we are having, let's say, 15 years experience of automotive world, doing millions of piston pin, for example, also finger followers, engine parts, and you can imagine our turnover is quite dependent still on engine parts. We want to move to the next solution. As I mentioned, tribology historically is a background. We diversified also in photonics, so coatings with optical features. Electric, you will find in there, for example, the coating for bipolar plates, but not only. And basically, what you see on the side is that we are vertically integrated. We produce our coating machines, we produce the coatings, we develop the coatings, we do the jobbing, and we have, of course, research and development and complete manufacturing supply, meaning that when we do something, we do it from the beginning till the end, including the robots, the automation, control, 100% control, camera control whatsoever. Technologies, two main technologies at HEF today. Thermochemical process, nitriding. Let's say that's the big half of the activity. The big second half of the activity is vacuum process. And basically, out of this, we do some components, very limited, but still with some of our technologies, we do bushings, mainly bushings for construction equipment, big bushings, high loads, oscillating, big stress. And we are, of course, as a surface engineering company, we investigate new fields of development, and we like to mix things together, and we do laser texturation. We have some industrial applications and also powder functionalization. Here's what it's all about today. Okay, so it's always like this. You do a 1-minute film, and the 10 important seconds, they are gone when you expect, to introduce your topic. But our moderator this morning introduced it right away, so I don't have to tell you, let's say, as a as a little teaser that, yeah, you need to wait for the film to know what we're talking about. So I explain it again. We are talking about the coating on metallic bipolar plate, which was also explained shortly on the film. Why? Why do we go into this market? We want to provide locally an economical, recyclable, and robust coating solution for metallic bipolar plates. You will see each of these words is important. Why do you think we are legitimate to do this? Basically, you need a lot of things to achieve that. You have to basically have, let's say, be first a PVD coating expert. That could help to start with. Automotive market knowledge, automotive control knowledge, ability to develop an inline equipment due to the geometry of the bipolar plate, and to industrialize a prototyping platform which we have already up and running to ramp up the production. And we had to invest also in a fuel cell dedicated lab, or I would say a bipolar plate dedicated lab. You will see why. A few basic, but I will go very fast. Just if you don't know, 2 kinds of bipolar plates today on the market, graphite ones, metallic ones, with coating, 4 different type of application. But I must say, I discovered on the fair those last 2 days that most of the people who were either on one side or on the other side are now trying to cross and check also what's the, let's say, a metallic plate can do for one who was only focusing on graphite plate and vice versa. So I think everyone is now much more open. And we are focusing, of course, on the metallic plate because you don't need any coating on graphite plates. One other important thing to know, you have 2 solutions with the coating. Either you have a pre-coating solution, and then you form the plate, okay, with the press, or you do the opposite. You press, you make the design of the bipolar plate, and then you make the coating. We go for this solution, post-coating. Why? We believe with the post-coating, you will reach the best performance-price ratio over time, okay? Because we know a fuel cell will have to be a high-performance, let's say, power unit. It will ensure the most robust solution, and we will have a price improvement of this solution when we multiply the different facilities. If you have a pre-coating solution, your facility will be probably only in one location. You will not be able to go close to the customer, and this is the business model that we follow. We follow the customers, we have small plants nearby, and we can do the coating almost as if it was in your plant. More important, 3 important things that we have to achieve as a coater on the bipolar plate. The first thing, the blue one, is, let's say, the most easiest thing. We have to have some good gas impermeability, okay, for the cell to function. More tricky, we have to ensure low resistivity, I mean at the interfacial resistance of the plate, and also excellent chemical inertia. So these 2 things I will detail how we achieve with a carbon-based coating. This is the next part. For this, our strategy is the same as what we develop in automotive. We have to be good at PVD coating development. We have to be good at producing high productivity equipment to get a good price for you. And in this case, we had to develop an e-chemistry laboratory. I'll focus on the coating. A coating is just something which is, let's say, from the process always the same. Parts cleaning, pumping in the machine, make a vacuum, have a plasma etching, then a plasma coating deposition, then a cooling. I don't go too much into the details, but then we developed, as I said, the e-chemistry laboratory. And basically, we have 3 types of tests to achieve. The one we can do alone, ex situ, corrosion test, resistance measurement, and then we want to do characterization with the lab, because we want to do also stress tests, check the durability, and then of course it's with the fuel cells maker we make stack validation at the fuel cell maker. So briefly, what we achieved, we have interfacial resistance as good as gold with a carbon-based coating. You can see we are low, and the two red and yellow curves are gold versus our carbon-based coating. Second, as I mentioned, it should be inert. So gold is inert, no problem, but expensive. We have a carbon which is almost inert, and which then can be considered as good as gold for this application. Last, the durability. You see two curves, 1/100 hours of stress test, 1,000 hours of stress test, equivalent to 10,000 hours in the real life. And one curve is after 1 hour. So you see the coating is not moving after the stress test. I never managed this. Anyway, high productivity equipment. This is my last slide. We have to develop this inline machine. It's slightly different from our batches, which we have today. But let's say the process is done in a different way. We want to achieve 10,000 fuel cells per year with one machine. That was my almost last slide. So we invest 25 million in this technology. And you can see, for example, if we have 5 machines like that, in 2025, 2030, it's about 50,000 PMFC
really
that
sorry,
we can
stick
do.
to the time schedule.
Just the boot, A61.
That was very important. We don't have time for questions right now, but if you want to talk to Guillaume, Chevret, A60 and A61. Thanks a lot for this interesting
Thank you for your
presentation.
listening.
Sorry that I had to interrupt you after this 10 seconds delay of the film. The film was also very inspiring as your presentation.
Thank you.
Thanks a lot, Guillaume.
Yes,
Chevret.
you can join 61.